Hello guys and welcome to this, yes, another VCAA video. This one is for the 2022 Paper 2, which I believe some of you will have just sat. Now, my name's Darren from Maths Guru. Thank you very much for watching. I know you want to get going with these answers, but can you do me a favour? If you haven't already done so, can you subscribe to my YouTube channel? It really just lets me know that you've watched, and it's so important to me. I know, again, it always sounds needy when I say that, but generally, if you can subscribe, it means the world to me. And if you can tell your teachers about my content on mathsguru.com as well. I know some of you would have used me on Edrolo. That's awesome. Edrolo was stopping my content this year, and so it would be lovely to know that people out there could still access the same amazing teaching. Yes, I talk about myself in that way, but really, so many people always stop me and say, oh my God, the stuff you do on Edrolo is amazing. You are the best presenter. That is great, great praise. All right, so I'd love for people to be able to do that. Why don't you email your maths teacher now and say, hey, Maths Guru, really good. Check out his website. Now, I'm going to go through these solutions now, and hopefully they will be all correct. But if it's anything like previous form, I, like many of you, will undoubtedly get tricked by a question. If I do, I'll put Errata down in the comments below. If you have questions or what have you, let me know in the comments on YouTube as well. If the video requires it, I will re-record sections and upload it again tomorrow, but we can all work together on this. All right, so shall we get started? Now, I haven't seen this paper before. This is me seeing it almost like you as well, but I will go through all sections. And if you look below you, there we go on that green bit there, it should tell you, well, mathsguru.com actually, and the particular section I am dealing with as we go through it. Data analysis. Question number 1, the back-to-back stem plot below displays the distribution of daily maximum wind speeds in kilometers per hour recorded at a weather station in April and November. Key, always really important. What have we got? We've got April, we've got November, we've got wind speeds, we've got numbers. For April 2021, so first things first, I'm actually going to highlight that because I don't want to mess up and get the wrong data. I want my eyes to be drawn to April 2021. Find the median wind speed in kilometers. We've got 30 data items. All right, so that means I'm going to have to find between the 15th and the 16th data item. All right, that's where my middle is going to be. So let me see. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. There we go. So it's between those there, which basically would give me 20. So in which case I'm going to write 20 there. Now again, it's always important when we do these things that we count in the right direction. So you always count out from the number if you're going up, or you would count backwards if you were going down. But in this situation, fingers crossed, 20 is my median wind speed. The percentage of days, it says percentage, let's not stuff that up, for which the wind speed is less than 25. The percentage of days for which the wind speed, and again, we're still on April 2021. So less than 25. So we've got, what have we got, 22. Right? Oh, this is interesting. This is actually split. I didn't notice that, but anyway. So we want basically to add all of these together. And let's see how many we got. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we would have 18 out of 30. And I'm going to times it by 100. So let's fire up my calculator. All right, what have we got here? So 18 divided by 30 times by 100 gives me 60%. Now again, I just want to check here, right? Again, it's always useful for me. I know those of you who are watching it, you've just had it, you want me to power through these, but other people will watch this video later on and I just want to make sure. All right, so again, what we've got here is we've actually split our tens, yes, have been split into 1, so what would that be? So that'd be 10 to 14 and 15 to 19. All right, so again, that's a little bit of a trick. So if we want 25 or less, well, our highest number here is 22. They're all zeros, and fingers crossed we get 60%. Now let's move on to part B. The 5-number summary for wind speed in November 2021 is given below. The wind speeds for November are to be used to construct a box plot. Show that the wind speeds. Now, I show that question quite specific. I've got to show enough working out to make this, make the examiners happy. Show that the wind speeds of 59 and 70 kilometers per hour would appear as outliers. Well, what they're really wanting us to do is firstly work out my fences, my upper fence and lower fence. So I know that my upper fence is equal to my quarter 3 plus 1.5 times the IQR. And I know that my lower fence is quarter 1 minus 1.5 times IQR. So again, firing up my calculator, and I am forever forgetting to turn this off at the moment, so my apologies if that happens. Well, I know that my Q3 is 35 plus 1.5 times my IQR of, well, I've got to work out my IQR. Let's turn this off for just a moment. My IQR is basically going to be 35 minus 22. So my IQR is 35 minus 22, which is equal to, right, 35 minus 22, 13. Again, you're going to say, well, why have I done that? I don't want to make a mistake. Okay, so this one here is going to be Q1. It's going to be 22 minus 1.5 times 13. I put this into my calculator. 35 plus 1.5 times 13 gives me 54.5. Bear with me, guys. I know you can't see me writing my answers down. You will do in just a minute. Minus 1.5 times 13, which gives me 2.5. So let's turn that off. What have we got here? So we've now got to show. So therefore, as 59 and 70, all right, I'm going to just take this up a little bit so I can write properly, are above 54.5, they are outliers. Now, there's a lot of work there for 2 marks. Again, I don't work for VCAA, I'm not marking this exam, but I am absolutely certain they want you to show that. And so to do that, you've got to also put down a statement that it was above 54.5, the upper fence, all right? So, so you show the exam. You can't just do the upper fence, the lower fence, and just write down, I don't know, anything else other than that. Now moving on to part C. On the grid below, use the data from the stem plot on page 2, okay, to construct a histogram that displays the distribution of wind speed for November 2021. Use class intervals of width 5, starting at 15 kilometers per hour. So the first thing I'm going to do is I'm going to scroll this up because I want to start at 15 kilometers per hour. That's where my first one is. And I want to go up in class intervals of 5. Right, now I know that you don't have the data with you, obviously here November 2021. If you want to try and do this yourself, by all means pause the video now and you can look at the data there to try and do it yourself. But obviously I've got the exam sitting beside me. So let's see what we can do. So going from 15 to 20, I've got 1, 2, 3, 4 data items, right? So it's 15 up to 20, but not including 20. So I've got 1, 2, 3, 4 data items. Now you are going to do this ridiculously accurately because you have to use a ruler for this. Yes, I am just going to use shading to give the indication. So between 20 and 25, I've got 1, 2, 3, 4, 5, 6, 7 data items. So again, you would have to do this ridiculously accurately. Now, boys, please don't sit and think that what I'm currently doing by just drawing it roughly straight is going to do. VCAA require you to use a ruler. And if you don't, seriously, you're going to lose marks. So 25 to 30, 1, 2, 3, 4, 5. So I've got 5 data items. So I'd come across here and I would go down. And there we do all this colouring in, Studio Arts. Joke, don't flame me. 30 to 35, 1, 2, 3, 4, 5 data items again. So I'm going to go across from 5 data items and down. 35 to 40, I've got 1, 2, 3 data items. So I'm going to go across and down. My goodness, this is time consuming. So much fun. 40 to 45, I've got 1 data item. There we go, so across and we're going to go down there. 45 to 50, we've got 2 data items. So let's do that one there. 50 to 55, I've got 1 data item. 55 to 60, I've got 1 data item. 60 to 65, none. 65 to 70, none. And 70, I've got 1 data item. So there we go. So, with any luck, if you've drawn yours accurately, that there is the correct answer to 1C. Right, moving on to question number 2. The box plot below shows the distribution of relative humidity at 9 AM and at 3 PM. All right, so again, I'm just going to highlight this, 9 AM and 3 PM at a weather station for the 30 days of November. Okay, determine whether the relative humidity in November is more variable at 9 AM or 3 PM. Now, if it's more variable, it's talking about the interquartile range, right? And actually, interestingly, it goes on to say here, the best thing to talk about variability, in my view, is the interquartile range. give the approximate values of our interquartile range. So the first thing I'm going to do is work out our interquartile range for this. So if you are happy that that is going to be the difference between those two lines there for that, for 9 a.m. and there for 3 p.m. So let's work this out. What is that value? That is 65. And that value there is 100, which gives me 35 as my IQR. I'm going to write that on there. And then what have we got here? So we've got about 51. And what have we got here? 80. And then 80 minus 51 is going to be 29. So determine whether the relative humidity in November is more variable or at 9 a.m. or 3 p.m. Give approximate values. In which case, the variability is less at 3 p.m., right? Because it's closer together than at 9 a.m. as at 3 p.m. The IQR is 29, which is less than, sorry about my handwriting, I'm trying to write quickly, which is less than 35 at 9 a.m. Now again, don't stress too much if you're not word for word. Again, this is my interpretation. VCAA will have their own, so long as you've actually answered the question, right? Because it says determine whether the relative humidity in November is more variable at 9 a.m. The variability is less at 3 p.m. And then quote statistics, you should be fine. The next part of the question goes on to say, write down the percentage of days in November for which the relative humidity at 3 p.m. was less than 80%. Okay, so looking at my diagram, there is 3% at 3 p.m. There is my 80%. How many sections of my block plots do I have? I have 1, 2, 3 sections. Each of those is 25%. Add them together would give me 75%. So 75% of the days in November would have a relative humidity of less than 80%. Complete the 5 number summaries for the distributions of relative humidity at 9 a.m. and 3 p.m. by writing the missing values in the table below. Again, if you want to pause, you can have a look at that there and write down the values if you wish to. But what am I going to have here? Right, so using my values here at 9 a.m., our minimum is going to be 40. Our third quartile seems to be coming out to be 100, and our maximum is also 100, right? Basically, if we look at this one here, we basically have our third quartile and our maximum at the same point. What about the next one? Our minimum was at 27, 51, 63. Our third quartile here was at 80. Just going to actually rub this out to make it look like 100 because my handwriting there was shocking. And our maximum was also 100. There we go. Fingers crossed if I got that right. And I've read these off. Please tell me I've got these right. What have we got here? We've got our minimum was 40. Yep. Third quartile and maximum was 100. Here, our third quartile was at 80 and our maximum was also at 100. Whew, job done. Do the box plot support the contention that there is an association between relative humidity and time of the day? Return to the values of an appropriate statistic in your answer. So I would say yes, there is an association, comma, as the time of day increases, the relative humidity decreases, as can be seen by the medians decreasing from, what do we have here, 75% at 9 a.m. to 63% at 3 p.m. So yes, there is an association. As the time of day increases, the relative humidity decreases, as can be seen by the medians decreasing from 75% at 9 a.m. to 65%. Now again, I've answered the question. I said yes, there is an association. I've said as the time of day increases, so I'm going back and looking at my diagram, right? So as 9 a.m. You know, as my time of day increases from 9 a.m. to 3 p.m., I notice that the median goes from here and decreases. And again, it is always important that you do your summary statistic. Now, it says an appropriate statistic. You could also have used the interquartile range, but obviously examiners will mark you accordingly. Moving on to question number 3. Table 1 displays the data for 7 weather-related variables in the first 8 days of December 2021. Write down the number of numerical variables in table 1. I loathe these questions. Numerical variables. Right, minimum temperature is definitely numerical. Maximum temperature is numerical. Rainfall is numerical. These are things I can measure. Maximum wind speed is numerical. Direction of maximum, no. Temperature is numerical. Now, it always comes down to day number. Is day number numerical? And I'm going to say no, because I can't average the day number. It doesn't make sense to add all those numbers again and say the average of the days was 4.3. It doesn't make any sense. That there would be categorical, but it will be ordinal, and likewise direction of maximum. So I'm just going to check minimum temperature, maximum temperature, rainfall. These are all things that can be measured. Maximum wind speed can be measured. Temperature at 9 a.m. can be measured 1, 2, 3, 4, and 5. So hopefully that there is going to be 5 as my correct answer. The median rainfall in millimeters for the 8-day period. The median rainfall in millimeters. So again, I tend to highlight these just so that I don't get messed up. I want the median. Now, I could put these into my calculator if I wanted to. I don't necessarily think that's going to make a lot of sense, because I can put these numbers, I can write the numbers out, even if it's like here. So I've got 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. I've got those. My next biggest number is 0.2. My next biggest number would be 1.0. And my next would be 11.6. So median rainfall in millimeters. So we've got 1, 2, 3, 4, 5, 6, 7, 8 numbers. What do I want? 1, 2, 3, 4. So my median is going to fall somewhere between 0 and 0. I'm going to say 0. Okay. And just so that I can check, because I really do not want to get caught up in this, I have actually just put all the data in. And as you can see there from my calculator, if I just go across and highlight where I am, the median there comes out to be 0. A least squares line is used to model the association between daily maximum temperature and daily minimum temperature. All right, with unrounded values for the intercept and slope, the equation of the least squares line is given as that. Round the intercept and slope to 4 significant figures. Now, if you don't know how to do this, guys, please, well, it's probably a bit late now. For those of you who are learning or doing this next year and looking over it, please learn how to round to significant figures. It comes up all the time, to 4 significant figures. So that's going to be 9.236. Right, because basically 1, 2, 3, 4, I've got to look at the 9, and that's going to change that 5 to a 6. And again, 1, 2, 3, 4 is going to be plus 1.002 to 4 significant figures. There we go, 1 mark. I like that. That was a nice easy mark. Moving on to part C of our question. Calculate the coefficient of determination for the association between daily max and daily min temperature. Write down its value as a percentage, correct to 1 decimal place. So if we go back to my table, what do I want? I want minimum and maximum daily temperatures, and I want to try and find my R² value. How am I going to do that? Well, fire up my calculator. Now, as it turns out, I've already got my data in there. So what am I going to do now? I'm going to go menu, I'm going to go statistics, and I'm going to go stat calculations, and I'm going to do a linear regression A plus BX. X list, we're going to say min temperature, Y list, I'm going to have max temperature. Click on OK, and lo and behold, what do we see here? So again, if I highlight my value of R² there, I get that my R², he says writing in highlighter, R² is equal to 0.611. Goodness gracious me, my eyesight is failing. Well, actually what I'm going to do is I'm going to copy that down. I'm going to go back to my calculator, and I'm going to take that value and multiply it by 100 to put it into a percentage. And then what happens? Well, we want it rounded to 1 decimal place. So rounding that value to 1 decimal place gives me 61.1%. So 61.1%. Moving on to question 4. The scatter plot below shows the relative humidity percent at 9 a.m. plotted against the temperature at 9 p.m. for the 30 days of November. A least squares line has been fitted to the scatter plot. Okay, the equation of the least squares line is given as that. The coefficient of determination is given by that. The equation of the least squares line can be used to predict relative humidity from the temperature at 9 a.m. Name the explanatory variable. Well, the explanatory variable is the one that is basically here, all right? If it's being predicted, all right, so if it says relative humidity is being predicted from, that is my response variable. That there must be my explanatory variable. So I will say temperature at 9 a.m. Describe the association between relative humidity and temperature in terms of strength and direction. Now, I've already now gone away and worked out my value of R. How did I do that? I fired up my calculator and I did the square root of the coefficient of determination, which gave me 0.779. Now again, you're going to be careful there because your graph is sloping down. So your R value is minus. Then because it wants the strength and direction, what did I do? Well, I looked at the table that was hopefully in your summary book. And basically when I looked at that, it told me that there was a strong negative association. Now it didn't say form, so it didn't want linear or nonlinear. It just wanted strong negative association. Interpret the slope of the least squares line in terms of the variables relative humidity and temperature. Right, I'm just going to turn my sheet over. Just give me a second so that I can get my equation. Right, determine the slope of the least squares line. So the slope is basically this thing here, and there is a very specific wording that I say to my kids over and over again. All right, that is negative, so there is a decrease. So what I say is, on average, because VCAA are expecting you to talk about it being on average, for every 1 degree centigrade increase in temperature, there is a 3.417% decrease in relative humidity. Now again, I know that VCAA tend to do it the other way around. I can't see how it'd be any different. But what I always do is say you start with on average. I always do for every 1 unit increase on the horizontal. It makes much more sense. That's always an increase going horizontally. So for every 1, you have to put the units, degrees C increase. In temperature, you have to put your units because it was temperature. There is a, and obviously whatever that value was there, 3.417, yep, 3.417%, because you've got to give your units, decrease in, and again, whatever your response variable was. On the day when the temperature at 9 a.m. was 16.3 degrees, I'm beginning to feel that there is a residual question. The relative humidity was 45 degrees. 45%. The following least squares line can be used to predict the relative humidity at 9 a.m. on this day. Calculate the residual. Right, the residual is equal to an actual value minus a predicted value. So the first thing I'm going to do is say, well, did we know the actual value at 9 a.m.? Well, it says, he says, highlighting on the day when the temperature at 9 a.m. was 16.3, the relative humidity was 45%. So my actual humidity was 45%. I'm now going to take away my predicted, right? So following that can be used to predict the relative humidity at 9 a.m. on this day. Calculate the residual value. All right, so again, what do we need? Well, the equation says the relative humidity is 120.1 minus 3.417 times temperature. And it said the temperature was 16.3 degrees. So I'm now going to say that my relative humidity is equal to 120.1 minus 3.417 times my temperature of 16.3. Firing up my calculator, because there's no way I can do that in my head, 120.1 minus 3.417 times 16.3. Always have to be careful of my handwriting, which gives me 64.4029. So minus 64.4029. Again, not showing you a calculator for this because hopefully you will be able to do this. So if I do 45 minus that answer, gives me minus 19.4 over da. And so I'd write minus 19.4 because it wants it to 1 decimal place. There we go. Now actually what I'm just going to do is go back to 16.3 degrees. Where's my 16.3 degrees? It's roughly this one here. And does it make sense for that to be a negative? Yes, it does. Roughly speaking, 10, almost 20. Did I get almost 20? I got almost 20. And again, it was always nice there to actually have a look and go, have I got the right thing? I absolutely have. The time series plot below shows the monthly rainfall in millimeters recorded at a weather station over a 36-month period. Oh, here we go. The time series plot contains irregular fluctuations. It does. Give two other descriptions of the pattern in this time series plot. So the first thing I would probably say is if we look at this, there is a decreasing trend. So I would looking at that, that's just a rough line. Don't read anything into that, but it seems to be going down. So I would say that there was a decreasing trend. And let's see, is it repeating every 12 months? It appears to be. So we're going up, down, up, down, up. So up, down, up, down, up. So I'd always also say there was seasonality. Seasonality, he says, not being able to spend. So there was a decreasing trend and seasonality. Now moving on to part B, write down the value of the 5 median smooth rainfall for month 20. Well, let's first of all find where month 20 is. Right, well, this is 18, 19, and there is my 20. So I'm going to highlight this one here. And if I want 5 median, I'm looking for 5 numbers, 1, 2, 3, 4, and 5. Right, so what I would need to do now is find the, well, there's 5 data items. The middle one's going to be third one, highest from the bottom. All right, so we've got 1, 2, 3. There we go. That one there is the third number from the bottom, which happens to fall nicely on 100. And so I'm going to say 100 millimeters. The data for months 1 to 12, the time series plot is shown in the table below. January, February, month number, yep. Calculate the 9 mean smoothed rainfall for month 7. Oh my goodness, for month 7. So we want 9. So I want 4, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So if I want the 9 mean smoothed, I'm basically going to take all of those values together, add them, and divide by 9. VCAA, that's rough, right? 129. See, I've already done it now. 129.6 plus 179.6 plus 206.2 plus 155.2 plus 127.6 plus 83.8 plus 61.8 plus 134.6 plus 122.8. Now I'm just going to check all of those because there's nothing worse than getting all the way through this and then finding that you've made a mistake. So let's just see whether we can go through these. 129.6, yep. 179.6, yeah. 206.2, yep. 155.2, yep. 127.6, 83.8, 61.8, yep. 134.6, 122.8. Enter. I'm going to divide that by 9, which is going to give me, and what it wants, round 1 decimal place, 133.5. There we go. So we want 100. He says, writing in highlighter again. I want 133.5. Okay, so now moving on to part 2. What would be the number of points in the smooth plot if the 9 mean smoothing is applied for the full 36-month period? Ouch. Okay, right. At the moment, we were centered around 7, which left these 2 data items here, spare, free, able. So that means I could actually move 2 spaces to the left, and the first point would be centered at 5. All right, so my first point would be centered at 5. Now, that would then allow me to basically, if I start from 5 from the beginning, if I start at 5 from the beginning, I'd have to end at 5 from the end. All right, so again, if it's 36 months, I've got 36, 35, 34, 33, and 32. He says, right, 22. So 1, 2, 3, 4, 5. So I would end at the 32nd data point. How many data points is that, including the 2 and the 32? So it's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and 32. I'm going to say that there would be 28 data points. And now let's move on to our recursion and financial modelling. Question number 6, worth 4 marks. Pina owns a workplace equipment which she depreciates in value using flat rate depreciation. The value of the equipment in dollars after n years can be determined using that rule. So it's always important to know that n is now in years. Determine V1. So I know that V1 is going to be equal to 200,000 minus 12,500 times 1. Fire up my calculator. Let's see what happens. 200,123 minus 12,500 times by 1. I know you're sitting there saying, why are you doing that? Would give me 187,500. Ka-ching. After how many years? After how many years will the equipment first have a value? Sorry, what? After how many years will the equipment first have a value of 0? Well, in which case I want 0 is equal to 200,123 minus 12,500 n. So I can now say that n is equal to 200,123 divided by 12,500. Fire up my calculator. 200,123 divided by 12,500 gives me 16 years. Whew. Right, so in which case n is equal to 16. Obviously there would have been another way to do that. I could have solved, let's just check, 0 equals 200,123 minus 12500 times n, comma n, hit enter, and n comes out to be 16. Easy peasy. The value of the equipment in dollars after n years can also be modeled by a recurrence relation. Write this recurrence relation in the terms of V0, V of n plus 1, and V of n. So the value after n years. All right, so in which case we would say that V0 is equal to 200,123. Don't forget the comma. V of n plus 1 is equal to V of n minus 12500. Now again, in this situation, the comma is important. If you use different letters, sadly, you're going to lose the marks. They've told you to do it in terms of V0, V of n plus 1, and V of n. Okay, using Pina's depreciation model, the value of the equipment decreases by a fixed percentage of its original value each year. Alternatively, the value of the equipment could have been depreciated by a fixed percentage of its current value each year. What type of name is given to this type of depreciation? It is reducing balance depreciation. Whew, there we go. Nice mark. Now moving on to question number 7. Pina invests 540,000 in annuity in paying 3% interest per annum, compounding monthly. Her annuity will provide a monthly payment of that for 10 years. Okay, always useful. So I'm just going to highlight this information. Compounding monthly payment 10 years. But information for payment number 3 is missing. All right, what is the value of payment number 3? I'm assuming because she's getting this fixed payment, it's just going to be 5214.28. Again, I had to think about that one for a little bit because I was like, right, calculate the interest associated with payment number 3. So what they're really asking me now for is this value here. Well, the first thing I've got to do is actually work out what my monthly interest rate is. How do I do that? Well, I'm going to take my yearly interest rate of 3%, divide it by 12 to get a monthly interest rate, and divide it by 100 to get a multiplier. Now, I've already done that on my calculator previously. I've got 0.0025. Now, what I'm going to do is actually check I got that right, because hopefully, if I take my previous balance, multiply it by that value there, I should get 1350. Now, that's just a check for me to make sure that I can actually do that. And as it turns out, when I did that, I got 1350. So I am fairly sure that my calculation is right. Now, all I need to do is to get this value here. I'm going to multiply my previous balance by 0.0025. Fire up my calculator. Let's see what we got. So I got my previous 532,261.78. I'm going to multiply that by 0.0025. Hit enter. I'm going to get. So I'm going to write this down and then say what comes up. So I've got 1330.65. Turn my thing off there. And I'm going to write 5214.28 there because I've got a feeling I'm going to use it. So calculate the interest associated with payment number 3. Round your answer to the nearest cent. So 1330.65. There we go. Let Pn be the balance in dollars of Pina's annuity after n months. Write a recurrence relationship in terms of, they like that, don't they? So what have we got? Write a recurrence relation in terms of P0, Pn, from month to month to month. So P0 is equal to my original amount, which is 540,000, comma, P of n plus 1 is equal to, now because it wants my monthly interest rate, well, I've already worked that out. All I need to do now is add a value of 1 to that to give me my multiplier here. So it's going to be 1.0025 times P of n. So that's going to add the interest on, but then we've got to take away the value of the payment, which was 5214.28. All right, because it's going to add on that little bit of interest, and then she's going to take it away. If Pina had invested the original 540,000 annuity as a simple perpetuity, what monthly payment would she have drawn? All right, well, in that situation, she would have ended up with, well, if it's 3% per annum, again, in this situation, if we were taking the 54000 and we worked out that each month she'd be getting 1,350. Hold on a moment. Now, I just want to check what monthly payment she would have drawn. Well, basically, remember, a perpetuity means that the start amount and the end amount is the same. So long as she kept withdrawing $1,350, she'd have stayed at $540,000, so $1,350. $1,350. Question 8. To purchase additional workplace equipment, Pina took out a reducing balance loan of $580,000, right, with interest calculated monthly. Took out a reducing balance loan. The balance of the loan in dollars after L months can be modeled by this recurrence relationship. So there's my start amount. There is my monthly interest rate, and that is obviously how much she's paying. Yeah. Show recursive calculations to determine the balance of the loan after 2 months. Now, when it says show that, and I'm going to keep saying this, you've got to show all the calculations. You can't just shortcut this. Again, VCAA for further maths are sadly going to take your marks off because it is so competitive out there to try and get 50s. So first thing I'm going to say is L0 is 580,000. Then I'm going to say L1 is equal to, right, 1.002 times 580,000 minus 3045.26. Write that down. Please don't just say, the exam doesn't know what I'm talking about, I'm just going to write down the final values. Don't. My understanding is that will lose you marks. 3045.26. Hit enter. That is going to give me 578,114.74. So L2 is going to be 1.002 times 578,114.74 minus 3045.26, which is going to be equal to, and again, I go 1.02 times that value there, minus 3045.26, gives me, and it wants it to the nearest cent, so 576,225.71, right? And again, you never ever round your values until the end of the question. Determine the annual compound interest rate for the loan. All right, so we know that there is my monthly interest rate. So what I'm going to do is 1.002. I'm going to minus the 1, which gives me 0.002. I'm going to times that by 12 and then times that by 100 to give me a percentage. So again, I'm going to do this off screen. 0.002 times 12 times 100 gives me an interest rate of 2.4%. There we go. The final repayment that is required to fully pay off this loan is smaller than all other repayments by an amount less than $1. Determine this small amount in dollars rounded to the nearest cent. Right, the final repayment that is required to fully pay off this loan is smaller than all other repayments by an amount less than $1. Determine this small amount. Okay, financial solver. I should Coco. Right, so bring up my calculator. Menu, finance solver. Let's see what we've got here. N, determine that, so, show recursively the balance after 2 months. To repay this loan, all right, so we don't know firstly how many months it's going to take. So I'm going to find the number of months. My interest rate was 2.4%. My principal value, it was a loan, so 580,000, positive, Payment is minus 3045.26. Future value is 0. It's 12 and 12. So I'm going to find my number of months. So in that situation, 239. So I'm going to write down over here, just over here, is 239.9999999 months. All right, that's when it's going to be paid off. What I'm now going to do is say, well, what happens when I pay 240 months? What is my future value? Okay, so when I put 240 payments in, what do I notice? Well, I've actually got a future value of 0.14. Now remember, if my future value is positive, that means that what? I am owed money. I've overpaid. So in that situation, I will have overpaid by, round to the nearest cent, 15 cents. So 15 cents. And again, for that situation, people always say to me, well, don't I round down to 239? No, you always have to take account of the fact that that extra payment would still accrue interest. That's why I've done 240 payments. If I do 240 payments, I've probably overpaid by 15 cents, or will have overpaid by 15 cents. So I would actually knock that off of my final payment. The original recurrence relation models a loan being fully repaid in a certain number of years. Using a different multiplication factor other than 1.002, oh, this is interesting, the loan would be fully repaid 1 year sooner. Determine this multiplication factor. All right, so let's go back to this. So it says, using a different multiplication factor. So what they're really saying is find a different interest rate. So this is going to be 0. Rather than 240 payments, it's going to be paid off 1 year sooner. So I'm going to take away 12 from this. That would suggest that I'm going to pay 228 payments. So let me just check, using a different multiplication, the road would be paid 1 year sooner. Okay, so they're only going to pay 228 payments. Determine the multiplication factor. So I'm now going to do there. So round your answer to 4 decimal places. So that seems 1.94%. All right, so I've got 1.946666, 1.94666. All right, that's a yearly interest rate. So I'm going to copy that, put it into there. I'm going to divide that by 12, and I'm going to add on 1. So divide that by 12, divide that by 100, because that's a percentage, and I'm going to add on 1, which is going to give me, and it wants it to 4 decimal places, 1.0016 should be my multiplier. And there we go, that's the end of the core section. I'm now going to work through each of the modules section by section. As you can see, there's matrices, networks and decision, geometry and measurement, and graphs and relations. Again, if you want to skip forward, you can actually look there along the orange bar, and it should tell you which section I'm on. Looking at matrices, if you can and haven't already done so, can you subscribe to my YouTube channel? Again, turn off notifications. I'm never going to spam you, at least I hope not, but it's going to show me that you actually watched the video. It means a huge amount to me if you can actually subscribe. Thank you very much if you are doing that. Also, follow me on TikTok, and hey, let your maths teachers know that I am out there doing this type of stuff, and actually I've got some really good content on Maths Guru. And why not say hello by leaving me a comment below? I pride myself on responding to all of those. Just give me a shout out. Greatly appreciated, yeah? Makes me feel not quite so lonely and desperate. Okay, so let's look at question number 1. Matrix C shows the nightly cost in dollars for 3 types of family accommodation of the ski resort. There's a hostel, a motel, and an apartment. Okay, the Dwyer family is planning to stay at the ski resort for 5 nights. Complete the matrix equation below to show the cost of staying at each type of accommodation for 5 nights. Well, the first thing is that's going to be a 5, and then I'm not going to bring up my calculator for this, guys, because it seems a bit silly, but I'm going to do, well, 5 times 80, and again, I'm doing this on my calculator so that I don't make any stupid mistakes. 400, 5 times 140 gives me 700, and 5 times 270 gives me 1350. There we go. The family has decided to stay at the motel for 2 nights and in an apartment for 3 nights. Okay, stay in the motel for 2 nights. So I know that the motel is $140 a night, and an apartment for 3 nights. Okay, write down the column matrix A for which the product matrix CA gives the total accommodation cost for the 5 nights. So write down the column matrix A for which the product matrix C times A gives the total cost. Right, well, I've got C. I'm just going to write this over here as 80, 140 to 70. And we want, what is that? So that is HM and A. So write down, so the families decided to stay for 2 nights in the apartment for 3, That's the motel. So 0 here. We don't want any nights in the hostel. We want 2 nights in the motel, and we want 3 nights in the apartment. So again, that should be 0, 2, 3. So if I just check, we've got C times A, 80 times 0, 2 times 143. Yep, that's going to be my correct answer. Question 2. Visitors can hire skis and snowboards at the ski resort. The following system of simultaneous linear equations represents 2 school groups of hired skis and snowboards, where X represents the daily cost in dollars of hiring 1 set of skis, and Y represents the daily cost in dollars of hiring 1 snowboard. Write the equations in matrix form. Okay, I like doing this because they've got the letters X and Y, so I know my letters X and Y go there, and then basically these numbers here go in there. So that's going to be 3700. and 4900. 1 mark. Show that the determinant of the matrix, that is minus. And again, it is a show that question. So what is the determinant? You take the opposite corners of the matrix, you multiply them and subtract them. So in which case I've got to show 20 times 50. All right. So again, it's that one times that one minus this one times that one. So minus 30 times 40. And again, because it's a show that question, I have to follow through all my workings out. 20 times 50 is 1,000. 30 times 40 is going to be 1,200. Take those away, gives me minus 200. Interpret the value of this determinant in relation to the solution of the simultaneous linear equations below. When you're working out the determinant, you're really finding out how many solutions there are, all right? Or if there is a solution or if there isn't a solution. Now, because that hasn't come out as 0, I know that there is going to be 1 solution to the equation. So I'm going to write, there will be 1 solution to the simultaneous linear equations. That's really why we work out the determinant. Complete the matrix below showing the daily cost of hiring 1 set of skis and 1 snowboard. Well, really what they're asking me to do is now solve that. How do I do that? Well, with a little bit of matrix algebra, or if you've already got this stuff in your calculator, it should be nice and easy. So the first thing I'm going to do is 20, 40, 30 and 50. I'm going to raise that to the power of minus 1, and then I'm going to times that by a 2 by 1. So let's bring that up there, of 3700 and 4900. Hit enter, and the fact I've got some nice numbers suggests I've probably got the right answer there. So it's going to be 55 and 65. All right, keep going. Question 3, students from a nearby school spend 1 school term skiing at the resort. 1 year, the school term begins on the 16th of July and ends on the 22nd of September. I'm already terrified about that. The resort has 3 different types of ski runs, each of which is classified as beginner, intermediate and advanced. Each day the students use 1 of the 3 types of ski runs. Matrix T below shows transition matrix, contains the proportion of students who are expected to change their choice of ski run from day to day. Okay, let Sn be the matrix that shows the number of students who choose each type of ski run n days after the 16th of July. So matrix S0 below shows the number of skiers who chose each type of ski run on the 16th of July. Okay, lot of language, yo! What have I just done there? Am I 12? No. Okay, so how many skiers are expected to choose the same ski run on the 17th of July? All right, so how many skiers are expected to choose the same ski run on the 17th? Well, this value here that I'm highlighting says that beginner to beginner is 70% of those who were beginners. So first thing I'm going to do is I'm going to do 70% of 210 people. I'm then going to say, well, hold on a moment. We've now got 70% of those doing intermediate continue. So I'm going to do 70% of the intermediate, which was 190. And then I'm going to add on the 80% of those doing advanced to advanced. So I'm then going to add on 80% of 80. Again, firing up my calculator. Hopefully you're happy that I don't show this, but 0.7 times 210 plus 0.7 times 190 plus 0.8 times 80 gives me 380. 344. So 344 people should remain on their same ski run. Right, looking at part B of our question. Consider the skiers who are expected to choose the advanced ski run on the 17th of July. What percentage of these skiers also chose the advanced ski run on the 16th of July? Okay, so let's look at the 17th of July first. So let's scroll up a little bit here. What have we got? We know that beginners to advanced, none of the beginners changed the advanced. I'm not worried about that 210. We know that 20% of the advanced changed. Sorry, 20% of the intermediate changed. There were 190 people, so we want 20% of those. And we know that 80% of the people who did advanced on one day did advanced the next. So 80% of 80. All right, so the first thing I'm going to do is just going to work out how many people on the 17th of July. So that was 0.2 times 190 plus 0.8 times 80, which gave me 102. Now again, what percentage of these skiers also chose the advanced ski run on the 16th of July? What percentage of those skiers? Well, 80 of them were there on the 16th. 80% of those basically transferred. So 0.8 times 80 gave me 64. So therefore, I'm now going to do 64 divided by 102 times by 100, which, and I'm not going to do this on my calculator, but when I did it on my calculator, sorry, I'm not going to show you the calculator, but when you do that on your calculator, it gives you 63% to the nearest whole number. Now moving on to part C, what is the maximum number of students expected to ski the intermediate ski run on any one day? Now when I first did this, I was like, oh, race T to a really high power, yada, 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 it all got very exciting. And as it turns out, nope, that was not the right answer. What you want to do is basically just trial and error it to see which one is the biggest value that the middle number gets to. Now what I'm going to say there is I'm just going to paste back my working out that I've already done. So there we go. So what I'm now saying is I'm going to try and raise this to different numbers, 1, 2, 3, 4, and see what happens. Or there might be another way of doing it by successively multiplying by t, which remember is my transition matrix. Right, so bringing up my t I inspire, you will already notice that I've defined my matrix, my transition matrix as t and my S0 there. So what I'm going to do now is just do S0, just to put it in my answer. I'm going to do t times my answer. So when I hit that once, the first number I get for my intermediate is 212. He's just writing in highlighter again, 212. Hit enter again, what do I get? I get 218.6. Hit it again, 219.04. What happens then? 217, it starts to go down. And what you notice, 215, 213, and it starts to go down. So it would appear in this situation, my biggest number, rounded to the nearest whole number, would give me 219. So therefore, the correct answer would be 219. Question 4, at the end of the school term, the students vote for who they want to captain the ski team for the next ski season. 3 students, Ali, Lee and Max, have been nominated for captain. 7 days before the end of the school term, the students were asked who they plan to vote for. The following table shows each candidate and the number of students who plan to vote for each candidate at the start of 7 days. Right, my first impression of this VCAA paper, because lots of people say to me, what do you think about the paper? Is there is a lot of reading. Yes, the rate I'm going, I'm never going to get this video out before midnight. Each day, all students are asked to join who they plan to vote for. It's expected that students may change the candidate they plan to vote for each day over the 7 days as follows. Some percentages are missing. How many students plan to vote for Ali after 1 day? All right, so what I'm going to do here is create a transition matrix. He says writing in highlighter, if only that was possible. So I'm going to say this and next. It's important to get my order right. So what have we got? Ali. I'm just going to turn my piece of paper over just so I can make this a little bit easier for me. What have I got? I've got Ali, Lee and Max. Ali, Lee and Max. All this for 1 mark. 40% of students who plan to vote for Ali 1 day will plan to vote for Ali the next day. So that's going to be 0.4. I'm going to put a line through that. 30% of students who plan to vote for Ali 1 day will vote for Leo the next day. So that's going to be 0.3. 50% of students who plan to vote for Lee 1 day will do Lee the next, 0.5. And again, that would have tripped a number of people up by not putting it in the Lee and Lee, or Lee and Lee. 30% of students who plan to vote for Lee 1 day will vote for Max. Lee 1 day will vote for Max. 50% of students who vote for Max 1 day will do Max the next. And 20% of students who plan to vote for Max one day will plan to vote for Lee the next day, 0.2. What do we know about the columns of a transition matrix? They are to 1. So so that's going to be 0.7, that's going to be 0.3, that's going to be 0.2, and that's going to be 0.3. What does it ask? How many students plan to vote for Ali after one day? All right, how many students plan to vote for Ali after one day? Do we have how many students there were? Yeah, number of people who plan to vote for 160. All right, so how many students plan to vote for Valley after one day? So Ali, one day, Ali the next, will be 40% of 160. So that's going to be 40% of 160. Now, I may well have done this, and it's actually for a different part of the question, plus Lee, one day, Ali next. So the number of voted for Lee one day is 140. So 0.2 times 140 plus Max was 0.3. times 180. Again, I'm not going to show my calculator for this because hopefully you guys can do that. So 0.4 times 160 plus 0.2 times 140 plus 0.3 times 180 gives me 146 people. All right, so 146 people will vote for Ali after one day. Max decides to withdraw his nomination after one day. Oh, that's a shame. Matrix D below shows the proportion of students who change their preferred candidate from one day to the next for the remaining 6 days after Max withdraws his nomination. At the end of the 7 days, who is expected to become captain of the ski team, and how many people will this person receive? All right, so first things first, we got to work out how many people voted for whom after the first day. So I'm actually going to go back to this one here, because that's my transition matrix. So I'm going to put that in my calculator, 3 by 3, yes please. I'm going to bring up my calculator so you can see it. So what do you got? 0.4, 0.2, 0.3, 0.3, 0.5, 0.2, 0.3, 0.3, he says, 0.3, 0.3, 0.5. I'm actually going to put that and store that as T, he says, not being able to, for some reason, store it. Nope. Come on, peoples. Control and store in T. I'm going to put that in T. For my transition matrix, right, so I'm going to do T times my initial numbers. So 3 by 1, hit enter, and what were my initial numbers? 160, and 140, and 180. So there we go. So after the first day, it is important to note that actually there were 146, 154, and 180. Yep, so that's great. That was my first day. So at the end of the 7 days, well, one day has already happened, so there's going to be 6 more days. So what I'm now going to do is take this transition matrix and times it by that for 6 days, which means I need to, I'm going to copy that transition matrix down. No, that may as well just copy it in. So there we go. So let's do a new transition matrix, 3 by 3, if you will, 0.5, 0. Oh dear. So 0.5, 0.7, 0.5, 0.5, 0.3, 0.5, 0, 0, and 0. Right, now I'm going to raise that to the power of 6 because there are 6 days. We've already had one day. I'm now going to do another 6 days, and I'm going to multiply that by 3 by 1, which is basically the numbers I could have just copied down from there. Please don't judge. 180, hit enter, and there we go. So at the end of the 7 days, who is expected to become the captain of the ski team? Well, I think in that situation, it's going to be Ali. Again. All right, and how many votes will this person receive? With 280 votes. And here we go, our module on network and decision mathematics. Thanks very much for watching. If you can, just leave me a comment below and say hi. Makes it just a little bit more worthwhile when people say hi. If you can subscribe to my YouTube channel, that's awesome. If you can reach out to your maths teachers and say, do you know what, Maths Guru, he's got a website. He's pretty awesome. He's got some pretty good stuff. Hey, use him, because Ed Rolo are dropping all my content and I still want to help as many people as I can. And then there's TikTok. Right, if you've done that and I finished feeling ever so needy, let's get on with networks and decision mathematics. Question 1, Joe owns a holiday park with 7 cabins. Oh, good. The diagram below shows a network of roads in the holiday park. Oh, good. Joe's office is labelled as a vertex on the network. There we go, so there's your office. The other vertices, A, B, C, D, E, F and G, represent the cabins. In the morning, Joe leaves his office and visits each cabin only once before returning to the office. Write down a route that he could follow. So I'm going to start with office, all right, and then I'm going to go A, B, C, D, E, F, G, office. Now, I could be wrong, but that seems ridiculously simple. In the morning, Joe leaves his office and visits each cabin only once before returning to the office. A, B, C, D, E, F, G, and office. Write down a route that Joe could follow. Okay. God, I hope I didn't get that question wrong. Later in the day, Joe will leave his office and travel along each road only once to check the road conditions. Which vertex will Joe finish on? Oh, right. Well, in that situation, if you're going to start and finish, you've got to end up on an odd vertex. So I'm going to add all the vertices together. That's 3, 2, 1, 2, 3, 4, 2, 2, 1, 2, 3, 1, 2, 3, 4, and 1, 2. So in which case, because you're going to start at one odd vertex and you're going to end up at the other one, is going to end up at vertex E. What is the name of this term for this route? Well, I fired up my textbook and it says an Eulerian trail follows every edge of the graph, is connected and has exactly 2 vertices with an odd degree. So I'm going to say Eulerian and trail. Now looking at question number 2, Joe plans to build or add a new cabin to the holiday park. The project requires 10 activities to be completed. The network below shows these 10 activities and their completion time in weeks. A, how many of these activities have 2 immediate predecessors? Right, an activity. So an activity is something that's coming off of one of the vertices. Right, and that was a bit of the trick to the question, which tripped me up the first time I did this video. I'm looking for 2 lines coming into an activity. So for example, if I look at that one there, H is coming off of that one, which means that F and D are leading into it. There are 2. Is there anywhere else that has got 2 leading into it? Yes, there is J. So if I look at that one there, it's got G and H leading into it. So let's just do that in highlighter. G and H is leading into it. There's one and there's another one. Can we find any more here? Now, when I did this the first time, I got tricked because the finish is not an activity. So although there are 2 leading into there, the finish is not an activity. So that one doesn't actually count. And I'm fairly sure I can't find any others with 2 leading into it. So my answer for that is actually going to be 2. Now, what is the minimum completion time in weeks for this project? Here we go. Oh, such fun. Let's rub those out. Let's draw all those annoying boxes. Now, obviously, there may well be quicker ways of doing this, but I've got a feeling that it's going to end up wanting me to backwards scan at some point, so I may as well rip the band-aid off now and do this before it gets too annoying. Rightio, so that's going to be 0, that's going to be 10, that's going to be 10, and that's going to be 10. So that's going to be 10 plus 3 is going to give me 13. That one there is going to give me 20. What have we got here? 10 plus 7 is going to give me 17. So, and what have we got here? 10 plus 12 gives me 20, so 17. 17 plus 5, 17, 18, 19, 22, and 22. So I've got a choice of 22 there or 22 there. Oh, that's nice. So which one am I going to choose? Oh yeah, that'll be 22. So now it starts now at 22. And this one here is going to start at 22. 22 plus 8 is going to give me 30, but we need to be careful because there might be a bigger value. Rightio, 20 plus 2, that gives me 22, so there's a 22 there. 22 plus 3 gives me 25. So 22 and 25, I'm going to choose the biggest. That's going to be 25. 25 plus 4 gives me 29. So I've got a choice here between 29 and 30. I'm going to choose 30. All right, what is the minimum completion time in weeks of the projects? 30 weeks. Okay. It is possible to reduce the completion time of 2 activities. One activity can have its completion time decreased by 2 weeks. All right, so I'm just going to write 2 weeks. And another activity can have its completion time by 1 week. Okay. These 2 changes result in the minimum completion time being reduced by 3 weeks. Okay. Complete the table below showing the 2 activities could have their completion times reduced and the reduction in individual activity completion time that reduced. Okay, he says, just mumbling to himself. What I'm now going to do is go back to my diagram and I'm going to write out all of the routes through this, or is it route? I get very confused in Australia because one year in a hotel I said I was going to plan a route for someone and well, everyone just collapsed. I thought it was the funniest thing ever. Still don't know what it means. Don't leave a comment in YouTube. I really am joking. I absolutely know what it means and I was very embarrassed because what made it actually worse was it was a religious group who were in the hotel. Yes, I used to work in a hotel on reception. Can you believe it? I know, go figure. Had nothing to do with the video, but it was a little bit of an aside. What I'm now going to do is write out all of the routes through this. So I can go A to B to E to G to J. Okay, I can go A to C to F to H to J. I can go A to C to F to I. And I can go A to D to H to J, and I can go A to D, A to D to I. There we go. Those are, I think, all of the different routes I can take. So 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. What I now tend to do is write on all of the length of time. So A takes 10, 10, 10, 10, and 10. B takes 3, so if I've got a B, I'm going to write that. C takes 7. D takes 12, E takes 7, F takes 5, G takes 2, H takes 3, and 3, I takes 8, and 8, and then J is 4, 4, and 4. Now what I'm going to do is add all those together just to actually go back and check that my 30 weeks is actually correct. So 10, 20, that's going to give me a completion time of 26 weeks. 17, 20, that's going to give me 29 weeks. What's this going to give me? Oh, dear me. 17, 17, 18, 19, 20, 21, 22, and 8 gives me 30 weeks. Oh, cool, we're doing well. 22, 22, 25, 29. And then what have I got here? 22, 10, 22, and 30 weeks. So that's interesting. We've got 2 critical paths here. Right, so we've got 2 critical paths. What I want to do, one activity can have its completion time done by 2 weeks and one can have its completion time decreased by 1 week. These 2 changes result in the minimum completion time being reduced by 3 weeks. So I've got to get it down to 27. I've got the maximum down to 27. Complete the table below showing the 2 activities that could have their completion times reduced. Okay, so looking at this one here and this one here, what do they share? Well, A, C, F, and I, they share A and I, A and I. So I can theoretically take one of those down by a week. So if I take A down by a week, then they're all going to reduce down by 1 week. Anything with A is going to reduce down by 1 week. In fact, I'm going to reduce A by 2 weeks in this situation. The reason being is they've all got A. So if I take this down by 2, that's going to give me 8. That's going to give me 24. Take that down by 2, there's 8 there. That's going to give me 27. Take that down by 2 is going to give me 28. Take that down by 2 is going to give me 27. And take that down by 2 also gives me, no, don't write that there because that's 8. Take that gives me 28. So now I've reduced my minimum completion time by 2 weeks. I've got 1 more week to go. So in which situation? I'm going to say for a moment, activity A, reduced by 2 weeks. What I've got to do now is reduce, basically, again, these 2 here by 1 week to get it down to the 27, because we've already got 27 here and 27 here. So I suppose the question is, what can we reduce? by 1 week, it's going to be I by 1 week. So I'm going to reduce I by 1 week. Now, the reason I've just paused there and sort of phased out a moment was I wanted to check, well, what would happen if I'd flip those the other way around? And I'll leave that as an exercise for you guys, because if I reduced I by 2, what would have happened? Well, if I'd reduced I by 2, let's do this in a different color. I'll try and do it in blue. If I reduced I, then this would have stayed as 26. That would have stayed as 26. This would have stayed as 29. This would have gone down by 2 to 28. This would have gone down, that would have stayed the same as 27. And this would have gone down to 28. Right, now, that would have taken my I down by 2, but I've only got 1 more week left. And the thing of it is, if I take this down by 1 week, it's only going to go to 28, and I need it to 27, if that makes sense. If not, I'd rewind the video and go again. But luckily, A by 2, I by 1. Part D, the holiday park has had some changes to its road to accommodate the new cabin. The adjacency matrix below shows road connections between the office and each cabin. The new cabin H is included in this matrix. All right, on the diagram below, add the new cabin H and any additional roads to the network. Again, I don't have a lot of room to be able to show you all of this. So again, if you want to do this on your own, take a screenshot of this if you are watching along. Pause the video, I don't know, take a photo, that would be a good idea. And then I'm going to scroll up and have a go here. Right, the office is connected to A, F and G. So the office is connected to A, F and G, that's already done. A is connected to the office, yep, B and just B, and the office is B. B is connected to A, yep, we've already got that, C, E and F. B is connected to A, C, E and F, we've already got there, okay. In fact, I'm just going to go down, oh no, because I don't want to, I've just got a feeling I'm forget something. C is connected to B, yes. D, yes, that's it. D is connected to C, yes. E, D is connected to E, and D is now connected to H. Right, on the diagram, add a new cabin H. So I'm going to put H here for a moment, and I now know that D is connected to H. E is connected to B, yep. D, yep. F, yep, and H. Okay, so E is now connected to H. There we go. I'm going to make that dot bigger. What have I got next? F is connected to the office. Yes. B, yep. E, yep, and G. What is that? Sorry. F is connected to G. Yep. G is connected just to the office and F. G is connected to the office and F. Yep. And H is connected to D. Yep. E. Yep. And oh, itself. Very clever. There is therefore a loop, because again, anything in a leading diagonal, so anything that comes down here means that there would be a loop, and there we go, we've got that loop there. So as far as I'm concerned, that diagram there would be my new H. Right, let's move on to question number 3. A series of pipelines is installed to allow for the flow of stormwater from the holiday park. The capacity of these pipes in litres per minute is shown in the directed network below. Okie dokie, so we got there. When considering the possible flow of stormwater through this network, many different cuts can be made. Determine the capacity of cut 1. So right, there we go. So there's my cut 1. When I teach this to my guys, then what I tend to do is say, right, shade one side of that cut line. So what I'm going to do is I'm going to use a bit of highlighter and I'm going to shade. And what I want is an arrow to basically be pointing from the shaded to the unshaded. Then I will count that cut. So if I look now at all the lines of the cutting, there's that one, that one, that one, that one, that one, and that one. So those are the lines I'm going to consider, whether they are going from the shaded or the yellow side to the non-yellow side, or the arrows pointing that way. Well, the arrow's pointing that way for that one, but it isn't for M to L, right? For M to L, the arrow's going from the shaded side to the unshaded. Don't like it, not having it. That one is included. He says rubbing it out, so let's put that back in. Change to my highlighter. This one here is included. That one there is included. That one there is included, as is that one there. So adding all of those together is going to give me the capacity of cut 1. So it's going to be 15 plus 15 plus 14 plus 11 plus 19, which when I add those together gives me 74. Ka-ching. All right, so there's part A. What is the maximum flow in stormwater, or of stormwater in litres a minute from the source to the sink? Right, for this one, I use an algorithm. All right, now this isn't a great algorithm. And in previous schools or previous lives, people have gone, oh, surely it's just all trial and error. And I didn't have a better way of doing it, but now actually we do. Now, what we do is we consider paths through the network from the source to the sink. So I'm going to deal with the one that I've just highlighted there. And what I'm going to say is, what is the maximum flow through just that pipe there? Well, it would be 15. So I'm going to take that smallest number, and what I'm now going to do is reduce the flow on that path by 15. So that's going to become 0, that's going to become 3, and that's going to become 5. And I'm going to write 15 here because I've reduced the flow through there by 15. You'll see where we're going this in a moment. Let's look at another path. And again, the most obvious path would probably be that one there. So 35, 20, and 19. Well, again, what's the maximum that can go through that? It's 19. So I'm going to write 19 here. And then I'm going to basically subtract 19 for everything on that path. 19, so that gives me 16 there. Now, again, another obvious path is probably this one through here. So again, if I leave that one on there, can you see which the smallest number is? It's 10. So for that path, the maximum that's going to go through there is 10. So I'm going to take 10 off of each of these numbers. That's going to give me 6. That's going to give me 0. That's going to give me 5. That's going to give me 9. And then take 10 off of there is going to give me 6. And there we go. Now, it doesn't matter what path I now consider through the rest of the diagram. I cannot get from the source to the sink using just those three. And just to prove, I can go along here, down here, along here, up here. Oh, can't go down there, it's a 0. Along here, can't go anywhere because it's a 0. Along here, up there, can't go because it's a 0. Along here, oh, can't go because the flow's wrong. Along here, down here, up here, 0. Everywhere I go, there's zeros. I can't go any further. So I'm now 100% sure that those numbers there added together will give me my maximum flow or my minimum cut, which when I add those together gives me 44. So the maximum flow is going to be 44. The question goes on to say, Joe would like to increase the maximum flow through the network. The maximum flow through the network may be increased either by reversing the direction of flow through one pipe or by increasing the capacity. All right, so the first one says the direction of flow of one pipe is going to be reversed. The pipe that should have its flow reversed to cause the largest increase in must go from vertex to vertex. Now, as a heads up, I stuffed this up the first time I did this question and got really annoyed. But let's look at the ones that could be reversed. All right, ML, and I'm deliberately saying ML because the water is flowing M to L, part of the trick of the question. If I reverse this one here, can water get through? Well, yes, there seems to be 5 and 3, so 3 could get through here. Reverse that, still gets me 3. Oh, no, it doesn't matter. I can reverse this. That 0 is still going to block it. Is there anything else I can reverse? Well, there only seems to be one other I can reverse, and that's Q to P. So if I look at this path here, now reversing that, is there capacity to flow through there? Yes, there is. It would appear 6, 9, 14, that would now be 12 and 6. So in which case the maximum I could get through there was 6. That is the only path that I could actually reverse. Yeah, again, you could turn around and say, well, what about if I reverse the 12? I can't get anywhere. It can't go through there and it can't go through there. So actually reversing the 12 makes no difference either. So in this situation here, if I was going to answer the question, it runs from vertex Q to P. And again, the first time I did this, I said P to Q, didn't read the question, didn't think, because at the moment it's running from Q to P. That's the one we would want to reverse. The capacity of one pipe is increased. So the capacity of just one pipe is increased. Copy the following sentences by filling in the boxes provided. The pipe that should have its capacity increased to cause the largest increase in flow from the source to the sink is. Right, now in this situation here, it sort of makes sense to try and increase the capacity of anything with a 0 on. Yes? Okay, and that's what I originally did, and I got a very different answer from the one I was going to do. So for example, if I was to increase the capacity of O to R, for example, well, sadly, if I look at the current flow or the capacity I've still got in that, it's only 1. So if I was to increase OR by 1, okay, there must be other ways of doing it. What about this one here? Well, I've got 5, 3, oh, okay, there we go. I can actually squeeze 3 through there. And believe it or not, a lot of people then maybe went, oh, well, okay, and discounted the rest of it. Shame if it was, there were other ways to get to this point here. There were actually a number of ways of getting in. So if I came along here and down here and up here and up here, water could also actually flow that way as well. So if I look at it, I've got 16 capacity there, 9, so 9, 5 and 5, which basically meant that another 5 could flow in that direction, which when I do the 3 plus the 5 meant that I could actually squeeze an additional 8 capacity. So if I increased L to R, I'd actually end up with a new capacity of 23. And where did I get that from? It's the 15 plus the 8, which gave me 23. So L to R, from L to R should be at least 23. Its new capacity in litres per minute should be at least 23. Obviously it could be 24, 25, 26. It doesn't matter. It's only going to be able to fit 23 through it. And there we go. That's the end of that question. There we go. Now welcome to Geometry and Measurement. Love, 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 love this module. Thank you very much for watching. If you can, subscribe to YouTube. Give me a shout out. Tell your maths teachers that Maths Guru is got his own website and the content's not bad. Errata are dropping all my content next year. That's up to them. Surprising, really, because apparently, according to lots of people, I'm a very good presenter. But I am on mathsguru.com. So if your maths teachers can, just get them to know that that is out there as well. TikTok, and as I say, just say hi on YouTube. I'm sitting in a room talking to myself at the moment. It's all very weird. So saying hi is great. Oh, and by the way, if you sign up on YouTube, turn off notifications. It just lets me know that you're watching. And again, I sound so needy. Right, geometry and measurement. And airships are made. Airships are a form of aircraft. An airship has a cabin in which the pilots and passengers travel and cargo is carried. This is shown in the simplified diagram below. The floor of the cabin is a rectangle with a length of 9 meters and a width of 2.5. The cockpit occupies an area 1.5 by 2.5 at the front of the cabin. This is shown in the diagram below. The remainder of the floor space is available for passengers and cargo. Okay, thanks. Calculate the area available for passengers and cargo in square meters. Okay, right. If I know that this whole thing here is 9 and that little bit there is 1.5, then basically that is going to be 9 minus 1.5. So 9 minus 1.5, which is going to give me 9, 8, 7.5. Yep, so that we know that that's going to be 7.5. That is 2.5, and so they are the dimensions there. So if I now do, therefore, 7.5 times 2.5, I'm not going to fire up my calculator to do that here. Hopefully you can do that. 7.5 times 2.5 gives me 18.75 square meters. And again, I just want to check the remainder of the floor space available for passengers and cargo. The floor of the cabin is a rectangle with length 9 and 1. Calculate the area available for passengers and cargo in square meters. Okay, cool. The cabin is a rectangular prism 9 by 3 by 2.5 shown in the diagram. Calculate the volume of this cabin in cubic meters. Well, the volume is going to be 9 times 2.5 times 3. Again, just putting that to my calculator. 9 times 2.5 times 3 gives me 67.5 meters cubed. There are 8 windows in the cabin, 1 at each end and 3 along each side. These 8 windows are identical rectangles. The height of each window is 0.85. The total area of the 8 windows is that. Calculate the length of each window. Okay, so if I've got the total area of all of them, then basically I can divide that by 8 to give me the area of one. So the area of one rectangle is going to be, so 14.62 divided by 8 gives me 1.8275. So that tells me that if I have the height of 0.85 times some value of x, it gives me 1.8275. So therefore, 0.85 times x is 1.8275. And again, I can fire up my calculator and I can do solve. Oh, he says capital letters. I don't think so. Oh, capital letters. I don't think so. Solve. 0.85 times x equals 1.8275, comma x. Enter 2.15. So therefore, the window length is equal to 2.15 meters. I'm just going to check that one more time. 1.8275 divided by 0.85 gives me 2.15 3.15. There we go. So a cable connects the airship nose to a large concrete block on level ground. When the 60-meter length of cable, all right, so that length there is 60 meters, is pulled tight, the nose of the airship is 55 meters horizontally from the concrete block. This is shown in the diagram below. Calculate the height h of the airship nose from the ground. Well, this is a right angle triangle, so there is a right angle there. That is going to be a Pythagoras theorem. So therefore, h is going to be the square root of 60 squared minus 55 squared. All right, so firing up my calculator, I want to do the square root. He says, putting the calculator in the right section, the square root of 60 squared minus 55 squared. It gives me 23.979. What does it want? It wants it to the nearest meter. So that's going to be 24 meters. So h is equal to 24 meters to the nearest meter. Now you don't need to write nearest meter. I'm just writing that because I'm so used to doing it. Part E, the airship body is modelled on the cylinder with a hemisphere at each end. The cylinder has a the cylinder has a length of 80 meters. This is very similar to the question in paper 1, and a diameter of 15 meters. In fact, very similar. This is shown in the diagram below. Determine the total length in meters of the airship body. Pardon? Okay, so the total length in meters of the airship body. Well, if I know that that's 60, this is a hemisphere of a diameter 15. So that must mean that that is half of 15. So I know that this length here is half of 15, which is 7.5. But that length there is also 7.5. So if I do 60 plus 7.5 plus 7.5, it just happens to be 60 plus 15, which is going to give me 75 meters. Moving on to part 2, the outside of the airship body is covered in fabric. Now I've just had a bit of a think about this one because I'm like, well, does that mean the cabin is? But because it says the airship body, I'm going to go with the airship body, just that bit there, okay? It's covered in fabric, except where the entire roof of the cabin is attached. So it means this bit here. Right, this cabin roof attachment means that 22.6 square meters less fabric is required to cover the airship body. Calculate the total area of the fabric required. So long story short, what it's trying to do is wanting me to find the area of that cylinder. So I know the area of a sphere is given by 4 pi r squared. Okay, so that is going to be the surface area of my sphere, 4 pi r squared. So that's going to give me 4 times pi times my radius squared. Well, we already know the radius squared is 7.5. So that's going to be 7.5 squared. Now, the reason I'm doing a sphere is because I've got a hemisphere on one end and a hemisphere on the other. Connect those together, I get a sphere. Now I want to find the area of the effectively, the curved section. And I know the area of the curved section is given by, well, 2 times pi times r times h. Now again, if you think about it, the area of a cylinder, if you remember, if we had a cylinder, is given by 2 pi r squared plus 2 pi r h. Now the reason being is there's 2 circles and the curved bit. So really I'm just looking at the curved bit here. So that's the 2 pi r h, which is 2 times 7.5 times pi times the height of just the curved bit, which is 60 meters. All right, so therefore the total surface area is going to be given by, let's fire up my calculator for this one, just so you can see what I'm doing. So 4 times pi times 7.5 squared, all right, that's the sort of the sphere, plus 2 times pi times 7.5 times 60. All right. Now, when I add all of that, that means that whole body is going to be 3534.29 dot 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 dot. But that's including the bit where the cabin is. But they've told me that the cabin actually is, or the cabin roof is 22.6 meters less. So I'm going to take off that 22.6. So I'm going to minus 22.6. And that is going to give me answer to the nearest square meter is going to be 3,512 square meters. Moving on to question 2. At Brisbane Airport, an airship waited for survey equipment to arrive on a flight from Frankfurt, Germany. The flight from Frankfurt to Brisbane is 23 hours. Now, I know if I was going to draw dots roughly on, then there is Brisbane and there is Frankfurt, and it took 23 hours to get there. All right. That month, the time difference between Frankfurt and Brisbane was 9 hours. All right, so 9 hours time difference, and that's going to be 9 hours behind. At what time and on what weekday did the flight leave Frankfurt if it arrived in Brisbane at 6:30 a.m.? Okay, so 6:30 a.m. in Brisbane. Well, that means that I'm going to take 9 hours off of that because I want to work out what the time was in Frankfurt when it arrived. So take 6:30 a.m. off that. 6:30 a.m. on Thursday. Let's do Thursday. So 6:30 a.m. 6, 5, 4, 3, 2, 1, 0, 11, 10, 9. So that means it was 9:30 p.m. on Wednesday in Frankfurt, right? So it's 9:30, 10, 11, 12, 1, 2, 3, 4, 5, 6. Just checking forward, that's 9 hour time difference. Right, so if that's what time it arrived Frankfurt time, and then I'm going to take 23 hours off of that, which means it is going to have left at 10:30 p.m. on Tuesday. So therefore my answer is 10:30 p.m. on Tuesday. All right, moving on to part B. The equipment was used to survey a site in South Australia. The airship flew from Brisbane to the survey site along a small circle. Assume the radius. All right, so first things first, when I tend to draw small circles, I'm like, there is my small circle. There is the center of my Earth. There is a radius there. So I know that's 6400. What I'm interested in is the angle in terms of the latitude, which is 27 degrees south. That means that this angle here is 27, and therefore this angle here is 27. And so I can use trig, because I know that that's 27. I know that's 6400, and that value there is x. So therefore, the adjacent hypotenuse is cos. The cosine of 27 is equal to x over 6400. X is equal to 6400 times by the cosine of 27. And when I type that into my calculator, it in fact gives me 5702 in terms of kilometers, right? So that's the calculation. Because it's a show that question, you must make sure that you show your calculations of where it came from, or you're not going to get the mark. Calculate the distance that the airship flew from Brisbane to the survey site. Round your answer to the nearest kilometre. Okay, so they're now saying, here we go, here's my small circle, and I have my radius of my small circle was given by 5702. If I can find that angle there, I can find that arc length, can't I? Because that's effectively what they're asking me to find, my arc length. Well, how do I find that? Well, I know they've gone from 141 east to 153 east. So if I do 153 minus 141, and I know this sounds silly, but I'm going to do this on my calculator, it gives me 12 degrees. So I know that that's now 12 degrees. How do I find my arc length? The angle that I've got over 360 times 2 times pi times my radius, which was 5702. So, firing up my calculator, let's do that with you watching. That sounds a bit weird, but anyway, let's do 12 on 360. Obviously, that's the fraction. So what I'm saying is I've got a fraction of a whole circle. I've got 12 out of 360 times the circumference of a circle, which is 2 times pi times my radius, which was 5702. Hit enter. It gives me to the nearest kilometre 1194 kilometres. The survey was done at night, as you do. 2 spotlights attached to the airship cabin base 8 metres apart were set at the same angle theta so that their beams formed a single spot when the cabin base was 15 metres above ground level. This is shown in the diagram below. Awesome. Okay, calculate the value of theta rounded to the nearest degree. So what have I got? I've got basically a triangle that's 8 there and 15 metres there. They're at the same angle. So that means I've got, basically, that's 4. That height there is 15. So can I find theta? Calculate the value. Well, I should hope so. Am I making this too simple? This seems very easy for this part of the question. I want this angle here, theta, which is opposite over adjacent. So tan theta is equal to opposite over adjacent, which is 15 divided by 4. Fire up my calculator. Don't do that. I do that every single time. Trig. Nope. I know. Trig. Tan to the minus 1 of 15 divided by 4 gives me, calculate the value of theta. So scrolling up a moment, that would give me that theta is equal to 75 degrees. Again, I'm just going to check that because it seems a little too simple. The survey was done like two spotlights attached to 8 meters apart. Okay, we'll set the same angle so the beams formed a single spot when the cabin base was 15 meters above ground. This is shown in the diagram below. Calculate the value of theta. Okay, I'm going to go with 75. Okay, so moving on to question 3, part A. After completing the survey, the airship flew south from the survey site with that longitude and latitude to Mount Gambier along the 141 degrees east meridian. Assume that the radius of the Earth is 6,400 kilometers. Calculate the distance that the airship flew from the survey site to Mount Gambier. Now again, that to me is just an arc length question, all right? And bearing in mind there was already one before, okay. Now I've already drawn a diagram here to sort of try and show what that would look like. So basically I am trying to find the arc length between 38 and 27. So the first thing I need to do is delete that 9 that I had before, because it's now going to make sense when I say that the angle between that is actually 11 degrees. Once I know the angle, then I know that the length, or the arc length in this situation, is going to be the angle I have, which is 11, divided by 360, times 2, times pi, times my radius of 6,400. So again, I'm not going to bring up my calculator for this particular one because hopefully you can do this, but 11 divided by 360 times 2 times, let's bring up my pi button, times my radius of 6,400 gives me, radio, round it to the nearest kilometer would give me 1,229 kilometers for 1 mark. Now, moving on to part B. In order to unload the survey equipment, the airship was lowered so the cabin base was at ground level. A person was waiting on the ground. Their eye level was 1.6 meters above ground and the top of a 2-meter tall vertical post intersecting the line slope of the airship nose. They were standing 2 meters from the post. The airship was 10.5 shown in the diagram below. Calculate the horizontal distance between the person and the airship nose. Now, I have a feeling there's another way of doing this, but I'm not doing it. Well, I don't know. I've been playing for a little bit. But to me, it just makes much more sense to say, well, okay, here is a triangle. All right, so if I look at that triangle just a bit bigger, I know that that's 2 meters. And I know the little bit here, the little bit, you know, at the top there is the difference between 2 and 1.6, which is 0.4 meters. Now, the reason I'm doing that is I'm going to find this angle. So when I did that on my calculator, I know that the tan of theta is equal to the opposite divided by 2. So when I fire that up and I do trig, 10 to the minus 1 of 0.4 divided by 2, I get 11.3 degrees roughly. So approximately 11.3 degrees. Now the reason I'm saying that is because I now know I've got a bigger triangle here. And that angle there is also 11.3 degrees. So if I now look at my bigger triangle, all right, let's call that x. I've got 11.3 there. That's x. Do I know this height? Well, yes, I do. I know that's 10.5 there, minus that 2 there, which gives me 8.5. So therefore, using that triangle, I know that tan of 11.3 is the opposite 8.5 divided by x. So the value of x, therefore, again, firing at my calculator, is going to be 8.5 divided by the tan of that angle there, which gives me 42.5 meters. That's suspiciously nice. So I now know that that value of x is 42.5 meters. Is that what the answer wants? No, because that's only the distance between here and here. It then wanted me to say, I think it was from the person to the airship nose, so I'd have to add on the 2 meters. So therefore the distance would be equal to 44.5 meters. Okay, again, I have a feeling there's another way of doing that. It worked for me, so I'm going to leave that one there for the moment. And here we go, we got the Graphs and Relations module. Thank you very much for watching. If you can, subscribe to me on YouTube. Turn off notifications if you never want to hear from me again. But by subscribing, it just lets me know that you watched. Greatly appreciated. Leave a comment to say hi. Let me know how you've been getting on. Obviously, I'm fairly sure most of you will never want to do math ever again. None. Let your maths teachers know if you can that there is mathsguru.com. Ed Rollo, those of you know me from Ed Rollo, are dropping my content. But obviously, I still want to help people. People keep telling me I'm pretty good on Ed Rollo, one of their better presenters, they keep telling me. But anyway, I would love for your maths teachers to know that my content is there as well, and it's a lot cheaper. TikTok. And yeah, hopefully you are well. Right, graphs and relations. Question number 1. A bed company makes and sells single-sized bed frames. The weekly profit in dollars from selling N single-sized bed frames is given by that. Calculate the weekly profit in dollars if 25 beds. All right, so my profit is going to be 130 times by 25 minus 1560. I'll fire up my calculator for this one just to show you that my calculator actually does work. But again, for many cases, I'm not probably going to do that. 130 times 25 minus 1560. Hit enter. Gives me 1690. So there's my profit. I'm going to put a dollar sign in there just so the examiners are very happy. Find the number of single bed frames that need to be sold each week in order to break even. Calculate the weekly profit in dollars if 25 single bed frames are sold. Find the number of single bed frames that need to be sold each week in order to break even. Well, break even means there is no profit. All right, so if they break even, there's no profit, then I'm basically trying to say that 0 is 130N minus 1560. So 1560 is equal to 130N. So N is going to be equal to 1560 divided by 130. And again, 1560 divided by 130 gives me 12. All right, in which case they'd have to sell 12 beds to break even. Sketch the weekly profit P of selling N single-sized beds for N is falling between 0 and 40 on the graph below. Now, if you can hear paper wafting, it's just because I'm trying to get that profit function back again. So we know the profit function was given by 130N minus 1560. So in which case, if I've got 0 beds, we already worked out we were going to be down 1560. So 1560. I'm going to zoom in massively here, because I'm going to try and do my line. So 1560 is going to be roughly speaking there. Now, the VCAA examiners are expecting you to be as accurate as you possibly can. What have we got there? What else did I know? I knew that the profit for 25 beds was given by 1690. So 25 beds, all right, was given by 1690. So pretty much there. How's this going to work now? Well, hopefully with technology, this will hopefully give me a nice straight line, which I can then pretty much project up to there. And hopefully that there gets the weekly profit of selling N single-side beds, yep, from whatever else. And we already worked out, and again, just check that that was right, that 12 beds would be needed to break even. And if we look at this point here, is it 12? Yeah, it's not 11 because each one of those lines along there is actually for 2. So there's 12 beds. Pretty happy with that. Now moving on to part D, it says the single bed frames sell for $350 each. An equation for the weekly cost to produce N single bed frames can be determined. Complete the equation. We know that profit is equal to revenue minus the cost, right? So how much you get in minus how much it costs. We know the profit function from the previous part of the question was given by 130N minus 1560 is equal to the revenue. Well, how much is it getting in for each bed? Well, $350. So that becomes 350N minus C. Well, we're going to try and work out what C is therefore. So that becomes C is equal to, so basically move that to the other side, 350N, that stays where it is, take away 130N from both sides, and add $1,560 in, gives me 350 minus 130. I know that sounds silly, but again, I don't want to do this in my head. 350 minus 130 gives me 220N plus 1560. So here we go. So 220N plus 1560. 560. And again, there may be other ways of doing this. I don't really teach a linear module. I sort of said that before, but fingers crossed this all makes sense. Question 2. The bed company also sells complete beds in its showroom. The bed company purchases mattresses from an outside source. Single mattresses cost $480. Queen size mattresses cost $1,200. How much would it cost in dollars to purchase 10 single size mattresses? So 10 single size mattresses at $480 and 7 queen size mattresses, $1,200. Again, I don't know about you, but that last question seemed complicated. And then we go to this, 10 times 480 plus 7 times 1200. Again, hopefully you guys can do that on your calculator. 13200. And I'm going to put the dollar sign as well. So how much would it cost in dollars per purchase those? An order for single size mattresses and queen size mattresses was placed recently. These 25 mattresses cost a total of $18,480. How many queen size mattresses were ordered? Okay, an order for single size mattresses and queen size mattresses was placed recently. There are 25 mattresses. Cost a total of, right. So we know that x plus y. What I'm going to say is that x is equal to my single and y is equal to my queen. So x plus y, the total of single mattresses is 25. And I know that a single mattresses cost 480. So x times 480 plus y times 1,200 is equal to 18,480. Why is that useful to me? Because once again, I'm going to solve this by simultaneous equations. So menu, algebra, solve system equations, solve system of linear equations. I've got two equations, x and y. So we're going to say x plus y equals 25. I'm going to say 480x plus 1200y is equal to 18480, which gives me 16 x's, and so it gives me 16 singles and 9 queens. How many queen size mattresses are ordered? Therefore 9 queen sized. Okay, so moving on to part C of this question, we've basically got sort of a hybrid function or a piecewise function or whatever you want to call it. And we basically know that we got a kink in it, and we know that that value there is 20. The kink is basically, there's S and there's T. So the first thing I'm going to do is I'm going to find that point there. How do I do that? Well, I know that it's 480 times S. So I'm going to find, let's call this value Y. So Y becomes equal to 480 times by 20. I've already done that on my calculator to give me 9,600. A lot of people think that's the right answer. It isn't. So this point here, so what we now know is that 420 times S plus P has to be 9600. The reason being is that this equation here starts at that point there. All right, so knowing that, okay, so 420 times S, which was 20, plus P must give me 9,600. I can use my calculator to effectively solve that. So let's do that. We're going to do solve. And there is other ways of doing this, and I'll show you in a moment. 420 times 20 plus P equals 9600, comma P gives me the P value of 1,200. So P in that situation is 1,200. The springs used in a mattress will compress by 32 millimeters. So here's my spring. Will compress by 32 millimeters when a force of 500 newtons is applied. The equation F equals Kx, where X is a spring constant, where K is a spring constant, is used to model the relationship between the force applied F and the Find the distance in millimeters of spring. Okay, so first thing is we know that F equals K times X. Well, the force of 500 led to a compression of 32. So K can be worked out as 500 on 32. So when I do my calculator, 500 divided by 32 gives me a K value of 15.625. So find the distance in millimeters. The spring will compress with a force of 800 newtons. Okay, so we now know, going back to this, we know that F is equal to Kx. We know a force of 800 is equal to K, 15.625 times X. So X basically is 800 divided by my 15.625 gives me a compression of 51.2 millimeters. Gosh, I hope this is the last question. The bed company manufactures queen size and king size bed frames. Each queen size bed frame takes 3 hours to make and 1 hour to paint. Each king size bed frame takes 4 hours to make and 2 hours to paint. Let X represent the number of queen size bed frames produced each week, and let Y represent the number of king bed size frames produced each week. Okay, there are certain constraints that must be met each week. These constraints are represented by inequalities 1 to 4. What is the minimum number of king size bed frames produced each week? Okay, so let Y represent the number of king bed frames. So Y is greater than or equal to 10. So what is the minimum number of king bed frames produced each week? It's going to be 10, right? So the number of king bed frames produced each week is greater than or equal to 10. So it's going to be 10. The graph below shows the feasible region shaded that satisfies inequalities 1 to 4. On a week in which 15 king-size bed frames were produced, what is the maximum number of queen bed-size frames that can be produced in a week where 15 king? So again, I'm just going to flick over some paper at the moment just to remind myself what this question is all about. On a week where 15 king-size, so let X represent the number of, so Y is 15. So 15. Where's 15? It's going to be around here. So let's draw a horizontal line through there, if you'll be so kind. All right, so on a week in which 15 king-size bed frames were produced, what's the maximum number of queen bed frames that can be produced? Okay, here's a good question. So I am going to suggest, reading off that, is going to be 43. Right, so in which case I'm going to say 43, on a week in which 15 king-size bed frames produced, what's the maximum number of queen bed-size frames that can be produced? And I'm just going to check here that that actually works by basically going to inequality 3 and inequality 4, just to test, because I don't want to be wrong for this one. So 3 times X, which is 43, plus 4 times 15. So what's 3 times 43? 3 times 43 plus 4 times 15 gives me 189. All right, so 189, is that less than 190? It is. And is X, which is 43, plus 2Y, which is 30, is that less than 76? It is. So on a week in which 15 kids would do, what is the maximum number of queen size beds? I'm going to say 43. Again, I haven't taught this module. I'm beginning to second guess myself all the time with these type of questions. Hopefully I'm doing okay with them. The company makes a profit of 210 on queen size bed frames and 350 on king size bed frames. Okay, we've got objective functions. Here we go. This is normally the stuff that I've taught myself in half an hour off of a cornflake packet. So strap in, guys, it's going to get bumpy. Company makes a profit, so my profit function, let's call it Z, is going to be 210 on, he says right in 201, 210 on, what is it, queen size beds, and let X be queen size, plus 350 on king size beds, which is going to be Y. Calculate the maximum weekly profit. All right, so again, I know that I've got to rearrange this to give me, so what I've got here, so 350Y is equal to minus 210X plus Z. Y is equal to minus 210X on 350 plus Z on 350. And I know for the Northern Hemisphere paper for this year, I stuffed up and forgot the minus sign. Luckily, still got the same right answer. That was more by luck than judgment. 210 divided by 350 it gives me minus 0.6. So Y is equal to minus 0.6X plus Z on 350. Now, the reason being I need to know that is I want that gradient of minus 0.6, which is basically minus 6 on 10, which is 3 on 5. Let's go back and see if we can come to my minus 3 on 5. So for every, so what is it, minus 3 on 5, so up divided by across. Okay, so for every 5 across I go, so for every 10 across I go down 6. All right, so for every 10 across I go down 6, 5, 6. So I'm going to draw a line between those 2 points. I'm going to make it even longer. Okay, so let's see. Calculate the maximum weekly profit. I want the maximum weekly profit. So please work this time. So if I am right with my sliding line, my maximum weekly profit is going to basically be there where that point touches. So he says, reading off, what is that point? I'm going to zoom right in. Let's see, does that move now? No. Where did that go? That was at 15. Is this one going to move? Yep. So it's this point here. So I'm going to draw a line there and a line there just so I can make absolutely sure. So it's 19 and 38. All right, so 19 and 38. 19, so y was equal to 19 and x was equal to 38. All right, therefore, my profit is going to be 210 times 38 plus 19 times 350. Again, I just want to make doubly sure on that one. Yep. And typing that into my calculator, it gives a Z of $14,630. Okay, now moving on to part D. The profit made on a queen size bed frame is reduced. Below what value must his profit fall so the maximum weekly profit will result only at the point 20,28 on the graph. All right, so 20,28 is this point here, he says, not doing that properly. Okay, now we knew that our Z function previously was given by 210x plus 350y. So rearranging that, if you remember, we got 350y was equal to minus 210x plus z, or y was equal to minus 210x on 350 plus z on 350. Now this here basically gave me a gradient of minus 0.6. What we're basically saying is we've got to find what the gradient is of this line here. If I find the gradient of that line there and make it ever so slightly less, yeah, because I've got to make it ever so slightly less, if I can find the gradient of this line here, then we are on a winner. So I know that that is 8 all the way up to 38. So 8 to 38 gives me 30, and the gradient and that is 60. Now probably if I look at this, I can probably find out the gradient was a half. Anyway, he says, but let's just check that again. So I'm going from, so for every one across, yeah, for every 2 across I'm going down 1. So 2, so it's rise over minus 1, so it's minus a half. So I know the gradient there is a half. So if I now change this value here, I don't know what it is, as actually being saying R on 350 is equal to 1 on 2, right? Because basically the gradient, we don't know what this value here is, but we do know that's 350. We're trying to find the value of this that will give me a gradient of a half. So in that situation, if I did that, I'd end up with R is equal to 350 divided by 2. Again, 350 divided by 2 gives me 175. So what that means is if my profit function was $175, it would actually sit on that line there. So what we want to do is we actually want the gradient to be, what do we want it to be? Greater than a half or less than a half? So we want it to be less than a half, all right? So we want this to be less than a half, because if this gradient here is less than a half, then we should end up having our line just touching there. So in which case we want our R value to be less than 175. So the profit made on Queen's is reduced. Below what value must the profit fall? In which case we've now answered the question as $175. Guys, I really hope that made sense. Right, so $175, I think I said, is my right answer. And believe it or not, yep, that there is the end of this paper. Thank you very much for watching. Hopefully it has made sense. Hopefully the answers are all correct. I've worked very hard on this and been recording for what feels like half my life. Please sign up to YouTube, just subscribe, turn off notifications. It just lets me know that you've been watching. Thank you very much for watching. Maths Guru hopefully has come through once again for you guys. And I hope to see you again. And if I don't, wishing you the very best of luck for your future. Take care. Bye-bye.